Hey, geometry people. We are in our last lesson for our whole Unit 3. So today we're going to talk about the last two lessons in the unit, which is lessons 6 and 7. And as I told you in the last lesson, we will be talking about pyramids and cones, which are three-dimensional solid figures that instead of going straight up the sides, the height goes up and it meets at a point at the top, like an upside down ice cream cone, right, or a pyramid shape. So a quick review of what you would have done in the warm-up in class before you started watching the video was just reviewing, and we're starting on page 61 in your book. It's just reviewing what the area of a triangle and the volume of a triangular prism are, okay? So the area of a triangle, when you have a triangle with a base length and a height from the base straight up to the vertex on the top, the area is 1/2 base times height, 1/2 times b times h. And why does that work? Because if you remember, we talked about this in class, a triangle is half of a rectangle, right? If you were to fill that out and make a whole rectangle out of it, this area of this triangle here is the same as these parts of the rectangle that you cut away. Okay, those two parts together are exactly the same size as that triangle. Okay, so the triangle is 1/2 of the rectangle with the same base and the same height. Okay, so that's two-dimensional. We took a triangle, which is flat on a piece of paper. What if we made it go 3D? So now we have what's called a triangular prism. And a triangular prism means that the base is a triangle, so the bottom of the figure is a triangle, so is the top, and it goes straight up. The sides go straight up from the bottom to the top. So the volume of this triangular prism, you start by calculating the area of the triangle base, and you multiply times the height from the bottom to the top, okay? And the same calculation works for a cylinder, which is a form of a prism, except it doesn't have flat sides. It has a round side that curves around. It has a circle for the base on the bottom and the same circle on the top. The sides go straight up. And so the volume is exactly the same calculation. You calculate the area of that circle base times the height of the prism. Okay, so in that case, it's going to be the base area for this circular one is going to be pi r squared times the height. Okay, so that's the volume if it's a cylinder. This is the volume if it's a prism. Okay, so we talked about that in the past lesson, and we talked about that in class before you started the video, I assume. Now, what if, here's today's lesson, what if the sides don't go straight up? What if they tilt in and it comes to a point at the top? That's called a cone if it's a round circle at the bottom coming up to a point, like an ice cream cone upside down. Or a pyramid if you have a triangle or a square or something on the bottom and all the sides come up to a point at the top. And you guys, there's a really cool pattern about that. And the pattern is, this is the part that you want to write down. The formula for the volume of a cone or a pyramid. The volume is 1/3 times. So this is what we're doing right now. You're writing notes. The volume is 1/3 times the base area times the height. In other words, it's 1/3 times the volume of the prism. Okay, it's always 1/3. Okay, if you've got a 3D solid figure that instead of going straight up the sides, it comes into a point at the top, it's always times 1/3. Okay, and here's kind of why that works. Because if you look at some of the sketches I drew from the introduction. If you have, say, a cylinder, like a soda can or a Coke can or an oatmeal box or something, right? And you've got a certain amount of space inside that cylinder. Well, if instead of coming to a circle at the top, if it cut in and only came to a point, that's much smaller. There's not nearly as much space inside that cone as there was inside the whole cylinder. So the area inside the cone is going to be a lot smaller. In fact, it's only going to be 1/3 as much. And the same thing happens with a prism. If instead of going straight up, you cut all the sides in to reach a point, you're cutting off a lot of the prism, so you're losing a lot of the space inside. So your volume will be much smaller. All right, so let's look at some examples. If we go to page 63, what we have here is both a cylinder and a cone inside the cylinder. So they both have that circular base. They both have a circle at the bottom. But the cylinder goes straight up. The cone comes into a little point at the very top. Both of those have a height of 12, right? From the bottom to that tippy point. That tippy point is on that flat top, right? So both of them have a height from bottom to top of 12. Both of them have the same circle base with the radius is 5. And the height is 12, okay? So let's calculate their volumes. So the volume of the cylinder is the area of the base, so the base area times the height. It's a circle, so the base area is pi r squared, right? Pi r squared, r is 5, times the height, which is 12. So that's going to be 25 pi times 12, which is 300 pi. Okay. The volume of the cone, if we're cutting into a point, is going to be 1/3 times the base area times the height. In other words, 1/3 times the base area is 25 pi. The height is still 12. And that's going to be 100 pi. Okay? So the whole cylinder with the straight sides has a volume of 300 pi. If it comes to a point and makes a cone shape, it's only 1/3 of that is only 100 pi. Right? Let's do one with a square pyramid. You don't have to draw this, but I'm going to draw it just so you can see what it is that I'm talking about. So the base is a square, okay? And the height is going to come up to a point. It's not going straight up. So every one of the sides comes up to a point like that, okay? Sorry, that was a little crooked. They're telling us that the height straight up, so from the base straight up to the tippy point, is 15. So the height is 15. We don't know the dimensions of the base, but we know that it is a square because it's called a square pyramid. So whatever this is, it's the same number. We don't know what it is, but it's the same. Okay? So how could we figure out what is the area of the base? What is the area of that square? Well, remember, volume equals base area times height. That's our basic formula. It works every time. Up, it comes to a point, so it's 1/3 times the base area times the height. Okay? Look at the problem. They told us the volume. We know the volume is 245 because they told us that. We know the height is 15. We know we need 1/3. The only thing we don't know is the base area. That's the only thing we have to figure out, right? So let's see how we can solve this. It's an equation. We're only missing one number, so we can solve for it. So we have 245 equals, we can do 1/3 times 15. 1/3 of 15, or 15 divided by 3 is 5, times A. Divide both sides by 5, and it turns out that A is 49. So the first question, what is the area of the base? It's 49 inches, so area is inches squared. Then the last question they have is, well, what is the length of one side of the base? So you guys, the base is a square with sides of x, and we know that the area is 49. Well, the area would be x times x, right? X squared. And we know it's 49, so x is 7, because 7 times 7 is 49. So it's a square, and each side is 7 inches long, okay? So that's how pyramids and cones work, all right? All right, so let's talk about spheres real quick, okay? So a sphere, and we're just going to do it super quick on page 73. We're just going to go down to exercise number 1. And I'm just going to show you real quick about a sphere. A sphere is a ball, like a basketball, a tennis ball, golf ball, I guess a perfectly round scoop of ice cream. It really only has one dimension. It only has one measurement. All we need to know is what the radius is from the center to the edge, because the definition of a sphere is that every single point on the outside of that ball is exactly the same distance from the center. That's what makes it be a perfectly round sphere, okay? So as long as we know what that radius is from the center to the edge, we can figure out the volume of the sphere. So in this question, they said the diameter is 12. Well, if you remember for a circle, the radius goes from the center to the edge. The diameter goes all the way across, okay? So a diameter is 2 radiuses, right? It's 2 radiuses stuck together. It's one radius that goes this way from the center to here. That's one radius. And then it has another radius that goes from the center the opposite direction. So those 2 radiuses together make a diameter. So if we know the diameter is 12, that means the radius is 6. Okay? And here's the formula for the volume of a sphere. The volume of a sphere is 4/3. So again, it's thirds. Remember the other one, it was 1/3. So for spheres, the volume is 4/3. So the volume is 4/3 times, almost the same as the area of a circle. It's pi r, but instead of squared, it's to the 3rd power, okay? Because we're 3D. So the volume in this case is going to be 4/3 times pi times 6 to the 3rd power, okay? And 6 to the 3rd power. Let's see, I didn't work that one out. So 6 to the 3rd power is going to be 6 times 6 times 6, right? Times 4 divided by 3 pi. So don't forget the pi. Okay? So that cancels. It's 2. So it's 36. 36 times 2 is 72 times 4. I'm doing this in my head, you guys. 72 times 4 is going to be 288 pi. Final answer. And we have units. Centimeters cubed, because this is 3D. So there's our final answer for the volume of a sphere. Okay? All right. So what if I wanted to do one more problem for you? And that was going to be on page 77 in your book. So page 77 in your book. Let me find that page for you because I want to do you one, like what if they did it in reverse? What if they gave you the volume and they wanted you to find the radius? So here we go. I just found that page. And this will be the last bit that we do here. Okay, so this is going to be on page 77. I'm just going to do this one. Number 1. They tell us it's a sphere. They tell us what the volume is. They want to know what is R. Okay. Well, here we go. We have a sphere, right? And we know that the radius is going to be the same all the way around the sphere, any direction. That's our R. We don't know what it is. But we have a formula. The volume of a sphere is 4/3 times pi times whatever the radius is raised to the 3rd power. Okay? And they told us the volume. They told us the volume was 36 pi. So 36 pi equals 4/3 pi times the radius to the 3rd power. Okay? Again, we're only missing one number. We have an equation and we're only missing one number, so we can solve it. So first thing I'm going to do, you guys, I'm going to divide pi out of both sides just to get it to go away. Okay, so now we have 36 equals 4/3 R to the 3rd power. Okay, it's getting better. If I want to cancel the fraction, I would just multiply both sides times 3, right? 3 divided by 3 cancels. 3 times 36 is 108 equals 4 R to the 3rd power. Okay. If I divide both sides by 4, that cancels and becomes 1 R to the 3rd. 108 divided by 4 is 27. So 27 is R to the 3rd power. Do you remember in one of the other lessons, I think it was the last lesson, we talked about a number that raised to the 3rd power equals 27. Do you remember that we said 3 to the 3rd power is 27? 3 times 3 times 3 is 27. So that's our R. R is 3. Okay? So you start with your volume formula, and you plug in any information that you have, and then you solve for the one piece that's missing. All right, and so that's how you might have to solve problems sometimes. Okay, you guys, that is the very end of Unit 3. So we are finished with Unit 3. You've got a problem set. We'll have a little assessment, and then we will move on to the next unit. Bye, everyone.